Hey guys, welcome back to another Algebra 1 video. We're going to continue working on systems of inequalities. So we've been talking about this before, and we did graphing at the very beginning of this unit, but I want to look in a little bit more detail at graphing inequalities in two variables. Before we began this module even, we did graphing inequalities in one variable. So think of this as if it was a system of equations, and we began it the exact same way. So if it was a system of equations, I would begin, if I wanted to graph it, I would have to get y equals all by itself, right? So that's what I'm going to have to do with this top equation. I'm going to move this x term over to the other side, and when I do that, I end up with a negative 2y. I'm going to do it up here so I have a little bit more room. Negative 2y is greater than a negative x, right? Since I'm moving it to the other side, I'm subtracting it from both sides, and then I have minus 6. Okay, now this is the part that a lot of people got hung up on that last chapter test. When I divide by a negative number, there's this rule that says if I divide by a negative, I've got to flip that symbol. So I end up with y is less than a positive 1/2 x and a positive 3. Real quick, I want to go over that again, why that's true. If I had, let's say 0 is less than 1. We know that to be a true statement, right? So let's just say I divide both of these numbers by negative 1. Okay, this is still 0. 1 divided by negative 1 is negative 1. Now which of these numbers is the bigger one? 0 is bigger than negative 1. I'd rather have $0 than owe somebody a dollar, right? Be in the hole a dollar. So 0 is greater than negative 1. That's why there's this rule that if I divide both sides by a negative number, I have to flip the inequality symbol. Now that I have this, I can graph it just like I would if it was an equation. I start at positive 3. That's my y-intercept. My slope tells me to go up 1 and over 2 in the positive direction, or I could go down 1 and over 2 in this direction. Keep going this way. Now, because it's an inequality, we have to decide, do I want a dashed line or a solid line? And it is going to be a dash line because we are not including the points on the line. We're looking for the values that are less than this. So we're going to look at all the values down here below this line and not including the points on my line because it's not equal to. So all of these ordered pairs here in this shaded region beneath my line are the solutions to this inequality. Now we need to graph the other one. We need to graph this one. There's an understood plus 0 here, right? So again, we start with that plus 0, that y-intercept. We put our point. And my slope is 3. That's understood to be 3 over 1. So I go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Or we could go down 1, 2, 3. 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. And again, it's a solid line. We're not including the points on the line because it doesn't say that it's equal to. It says it's less than. And again, it's less than, so we're shading beneath it. So what area got shaded twice? I like to go back and just erase the area that only got shaded once. And that's all of this right in here. And that's all of this up here. So this area down here, we can put a star on a possible solution. So let's see here. Let's get my marker and let's make it green. And we're going to put a star right here. This point is a possible solution. I mean, any of these points down here in this double shaded area is possible solutions, but definitely negative 1, or this positive 1, 2, 3, 4, negative 1, negative 2. So 4, negative 2 is a possible solution to this system. Any of these points in this doubly shaded region are solutions to this system. Okay, so let's do this next one. All right, and let's look at this one. It says, remember that parallel lines have the same slope and different y-intercepts. So I know immediately that these are parallel lines because they have the same slope. So now we've got to graph them and work on the shading. So start at positive 2, and I go up 1 over 1, up 1 over 1, up 1 over 1, This is the top equation, or inequality, I guess. And because it's equal to, we want to connect the points with a line. We don't want a dashed line, we want a solid line, because that shows me that it could be all of the points on this line, or it could be all of the points below this line. So everything below it, because it's less than or equal to. Okay, so now we're going to look at this one. Start at -3. 1, 2, 3. Go up 1 over 1, up 1 over 1. Again, it's going to be a solid line because they are equal to. It is greater than or equal to. So we're going to connect those points. Pretend I connected those. And we're going to shade above it because it's greater than. So what area got shaded twice? It's the area in between. So all of the ordered pairs in between and on these two lines are solutions to this system of inequalities. All right, I hope that made sense. That's all I have for this lesson. I'm going to call it quits. Have a great day, guys. So I want to go over this problem again real quick. I made an error in my previous video, not paying attention to which equation I was looking at. So looking at the top one, we add 3x to both sides, then divide everything by 4. On the bottom one, we subtract 3x from both sides, and then I have to divide by -4. So when I end up graphing them, this one that's -2 is a solid line because it has the equal to, and we're shading all the values below it. And on this one up here, we're shading everything above it, but it's a dashed line because we don't want to include it. So notice that there is no area that's shaded twice. So in this problem, there is no solution. This is an inconsistent system. There is no set of ordered pairs that's going to make both of these inequalities true. So I definitely wanted to fix that mistake.